All right, let's plug into the single most important document in the electrical world, AS/NZS 3000. Now, I know what you're probably thinking, a huge, complicated rulebook, right? But what if we looked at it as what it really is? An essential guide to keeping literally everyone safe. Okay, let's get into it.
So here's the deal. By the end of this short explainer, you are going to have a solid grip on the core principles, the key safety features, and exactly how these wiring rules show up in the real world. No jargon, just the stuff you need to know. We've set this up like a guided tour. First, we'll talk about why this standard is basically the electrician's Bible. Then, we'll dive into the core safety principles that protect all of us. After that, we'll see these rules in action. And finally, we'll hit the most crucial last step, the final checkup. Okay, let's start at square one. Why is AS/NZS 3000 such a big deal? Well, because it lays down the mandatory foundation for every single electrical installation across both Australia and New Zealand. No exceptions.
When you boil it all down, the standard has one main mission: stop people from getting electric shocks and prevent property from being damaged. It's the absolute baseline that makes sure every job, whether it's a single light switch or a massive factory, is safe, consistent, and totally compliant.
Now, the standard is split into two main parts, and this is key. Just think of part one as the why. It lays out all the big picture safety ideas. For example, part one says every circuit must be safe. Then you have part two, which is the how. It gives electricians the practical, hands-on rules for how to make it safe, like exactly which size cable to use and how to install all the protective gear. So one's the theory, the other's the action plan. So let's see how those principles actually get put into practice. It all comes down to what we can call the pillars of protection. These are the absolute non-negotiables that are at the very heart of the standard.
First up, the RCD, or residual current device. You've got to think of this as the lightning-fast seatbelt of your electrical system. If it senses even a tiny, dangerous trickle of current going where it shouldn't, like through a person, it shuts off the power in a fraction of a second. Seriously, these things are lifesavers, and that's exactly why they're now mandatory pretty much everywhere.
And here is where they live. This is a great shot of a modern switchboard. You can see those individual RCDs, each one protecting a specific circuit. One for the aircon, one for the oven, one for the lights. The beauty of this is if one circuit has a problem, the RCD only trips that one and the rest of your house stays on.
So, the million-dollar question: when are they actually required by law? Well, for any new house, the rule is simple. RCDs have to be on all the final circuits. We're talking everything that powers an appliance or a power point you plug into. In commercial buildings, the focus is more on high-risk spots, so they're mandatory for all socket outlets and lighting circuits up to 32 amps.
Okay, the next pillar of safety is earthing. So if an RCD is the seatbelt, think of earthing as the emergency exit for runaway electricity. If a live wire ever touches something metal, like the case of your toaster, the earthing system gives that dangerous current a super easy path to flow straight into the ground. That causes a massive surge of current that trips the breaker instantly, stopping that metal toaster from becoming live and incredibly dangerous. Now, these protective devices are amazing, but they're only one piece of the puzzle. The whole system has to be built to handle the amount of power it's going to use. So how do you figure out how thick the cables need to be so they don't get overloaded and, catch fire?
The answer lies in calculating something called maximum demand. It's basically an educated guess of the highest amount of electricity a building will pull at any one time. You have to imagine everything running at once: the aircon, the oven, the works. Nailing this calculation is absolutely critical because it tells you exactly how big your main cables need to be to handle that peak load safely.
Okay, that's enough theory. Let's move on from the principles and see how these rules actually look inside the buildings we use every single day.
In a typical home, the rule is beautifully simple and incredibly effective. Every single final circuit gets its own RCD protection. That's your lights, your power points, your cooktop, your hot water system, your air conditioning, everything. The whole idea is to create a complete safety net around the entire house.
Now, in a commercial building, the approach is a little different. It's more targeted. The rules zero in on protecting the circuits where people are most likely to come into contact with electricity. So that means all the regular power points and the lighting circuits up to 32 amps need RCD protection, covering the areas where staff and the public are plugging things in and out.
The standard also gets super specific about certain high-risk areas. In damp places like bathrooms or near swimming pools, the protection requirements are even tougher. For big appliances like an air conditioner or a hot water system, you have to install a lockable switch right next to the unit itself. That way, a technician can safely turn it off and lock it before they start working on it. Even gas appliances need an accessible power point so you can easily unplug them.
And that brings us to the final, and you could argue, the most important part of the entire job. You can have the most brilliant design and the neatest wiring in the world, but it doesn't mean a thing until you've proven that it's safe.
This is a massive principle in the standard. It is not enough to just say you followed the rules. Every single new installation has to be put through a whole series of tough tests to prove, without a shadow of a doubt, that it is 100% safe and compliant before anyone is allowed to use it.
And this is not some random checklist an electrician just makes up. No way. AS/NZS 3000 spells out a mandatory, very logical order for all the testing. Following these steps ensures that every single part of the system is checked correctly, building a complete picture that proves the installation is safe from the ground up.
It all starts with a really detailed visual inspection. Then, with the power safely off, the electrician does a bunch of dead tests, making sure the earth connection is solid, checking that the cable insulation is perfect with no hidden leaks. Only after all that is the power turned on for the live tests, which confirm all the wiring is the right way around and that the safety devices will actually trip super fast if there's a fault. And the final step? Testing every single RCD to make sure it works. Getting a pass on this whole battery of tests is the ultimate proof that the job was done right. It's the final sign-off, the guarantee that the installation doesn't just look good, but that it functions safely, exactly the way it's supposed to.
So, let's do a super quick recap. AS/NZS 3000 is our roadmap to electrical safety. Remember, Part 1 is the why, Part 2 is the how. The core of it all is those life-saving RCDs, our electrical seatbelts, and the critical earthing system, our emergency exit for fault current. And maybe, most importantly, all work has to be proven safe with a strict sequence of tests.
And that's our look at the essentials of the wiring rules. It's so much more than a book of regulations. It's a framework that makes sure safety, compliance, and best practice are built right into every single circuit. Thanks for watching.